Welcome to the second week's worth of lectures. Sorry, we had a little bit of a delay because of the weather, but we'll try and get to some of these. So I'm going to put several of the codes that start with two underscore a number, and there's a few of these codes, and that we'll put them in two or three different videos. So let's start with the first one, okay? And so I'm going to go to my folder, and I see here code 2_1, and I am going to, of course, edit with idle, and you'll see that the code is now open. Okay, and so if you look at this code, you'll see that there's an assignation, and I'm going to say there's a number equals 10, and is positive, number greater than 0. So here you're asking the question, is number greater than 0? So it's almost like you're creating a condition, but remember, as we saw in the last set of codes, you can actually print a conditional, you can print a decision. Now, what happens, for example, if I have number equals 10? It doesn't necessarily have to be a number. For example, the number has to mean something. It's the same thing with is positive. And once again, with is positive, this is not about, I could call it apple, right? I can give it any kind of assignation. The reason why I'm going to call it is positive, or Ann Dawson calls it is positive, is because you want to provide a little bit of a clue as to what you're asking. So, if it says is positive, it tells you that you're asking a question. And is a number greater than 10? That's the assignation. That's the is positive assignation. And then you print is positive, right? And so you know that you're likely going to get true or false. In this case, I expect it to be true. So we're going to run this code, and I'm going to hit F5. You'll see the executed code, which I'm going to expand a little bit. So you see the executed code it's true. Again, what is the question is positive, and once again I said is positive really doesn't mean much. You could call it anything, an assignation, and as long as you're consistent with the assignations, and you're going to print is positive. Now let's go to the next code, and that is 2_2_2, and I'm going to open it in idle. And here's my script. So the question is, you're making an assignation, and you're creating a string, and you're going to call it x equals spam. And let's not worry about the commented one. We'll look at that soon. So the question then, the conditional then is, if x equals spammy, okay, print hi spam, okay, nice weather we're having, have a nice day. If it's not spammy, okay, then you print not having a good day. Okay, so obviously in this case, you're going to call something spam, and you're going to call x equals spammy, but obviously in this case x is not spammy, it's spam. So what you're going to see here is not spam, not having a good day. Okay, so let's execute that code, and you'll see it's not spam because you assigned x equals spam, so not having a good day. That was the question, right? So now we can go back to the script, and we can say we can comment out the x equals spam and uncomment out x equals spammy. So that's the one that's going to be operated. Obviously we save, and as we execute, watch what happens. Is hi spam, nice weather we're having, have a nice day. Let's go back to the code. Let's go back to the script, and this is a loop. So this is the conditional, if x equals spammy. Okay, remember, everything has to be indented, and everything that is associated with this has to be in the straight line. That is, it has to be one below the other. And remember the colon at the end of at the beginning of a loop, which indicates that this is a loop. It's the same thing with else. You have a colon which indicates the loop, and that's something to remember about this code. All right, let's go to the next code. And so here we have potential grades, right? So here you have the score. Now you're going to enter a score, and you're going to input that information, and then it says no matter what you put, it's going to take that score and it's going to write it, convert it into an integer. Okay, so it's the nearest integer. Then we could also try float score the next time, but it's going to convert it into an integer. So then you say, and this is this nested loops. Again, the rules are the same for every loop. You will have the colon at the end of it, and again everything has to be correctly indented. Okay, and we'll see how that works. So if the score is greater than 80, grade equals A, and then you're done, right? Then you're done. Now if it's not greater than 80, okay, not greater than or equal to 80, you say else. So now you have another else, because now you have several nested loops, because you want to have different ranges, different range of scores. So you say else if score is greater than or equal to 70, the grade is B, okay, which means 70 to 80, and that's why we have to identify the 80 first, because if it's 80 or greater than 80, then your code is done. Okay, and again if, but notice how this if and this else are aligned. Okay, then this grade, because this is aligned with this, okay, else if score is less than 50, greater than 55, then you have C. Else then if you have a score greater than 50, which means it's greater than or equal to 50. So if we have 54, for example, you're going to have a pass, and else the grade is fail. And you see the step down, the way it works is we have 80, 70, 55, 50, and if not, then it's failed. And print, here you'll have two carriage returns to give it a little bit of space after, because remember something, after here you don't have a carriage return, and then you add the grade, okay, whatever that grade is equal to. Once again, the same rules apply. Note the indents, they're correct. If and else have to be indented, and this has to go lower, this has to go one indent further here, and you see the indents, they all seem all correctly aligned, and we'll play around with it a little bit. But let's run the code. Okay, and you enter the score. Now you can enter anything you want. So let's just enter the score of 56, in which case the grade is 5. And you realize here that, if it was 55 and above, it was a grade of C, and that's the grade you have. Now let's kind of mess around with this a little bit. What happens if I move this one back, or just add a space so that it's not aligned with this, and let's see if it runs. And clearly you know that it's not aligned correctly with this grade, right? So that's an error that needs to be fixed. Okay, so I just put it one step, okay, and now it runs without a problem. Now this is the exact same script. Okay, but now you're being introduced to another conditional. So rather than say if, and if it's not that, then else, and then it's else another if and another if and another if, you could have your else and if combined into one command, which is called elif or elif, depending on how you want to pronounce it. And again, you realize that this code is the same. So rather than else, then another if, which is further indented, we just have everything associated with this code. That's like saying else if, else if, else if, else if. Okay, and you'll see everything else about the code is the same. The operative point here is that it introduces a new term, elif or elif, and the colon, obviously, because this is the loop, and the colon applies in every case. All right, so I'm going to just make sure I save it. Then we execute. And again, we'll potentially go with a higher score, and you expect the grade to be A. And now you're looking at a code that has something to do with a loop, but that loop is now going to specify a range. Okay, and you do not have to specify the range. You do not have to specify a variable before. Okay, you don't have to say, well, my C is going to be something. You don't have to specify it. What you have to do then is just put C, then, and the code will automatically know for some C, some variable, some integer, for example, in range 5 to 10, print C. Okay, so I'm going to save it, and I'm going to run it. Executed part, we have 5, 6, 7, 8, 9. Now this is very important, okay? Whenever we do Python, whenever we list terms, you always start with the 0th term. So because of our range here is 5 to 10, you'll see that the range is the 0th term till the second to last term, okay, or the second to last term, yes. And therefore you'll see here that it goes from 5 to 9, and you'll see this all the time. And so if you wanted to print out that number 10, then you want to be able to change the code from 5 to 11. Okay, you want to change the code from 5 to 11, and now you'll see it in operation. Okay, so always remember, it starts out, any type of range starts out with the 0th term, and then it'll always go up to the second to last term. So in the first case, it was 5, 6, 7, 8, 9. Okay, always remember, that's how things are listed. That's how numbers are listed. And this is just so you don't make mistakes. Okay. The script now identifies something very similar. Look at this code. This part is the same as before for C in range 1 to 6, which means the 0th term is 1, and then you would go up to 5. And it would say if C, there's another conditional, if C is equal to 3, continue, okay, and print C. So what do you think is going to happen? So now we have to ask ourselves, what does this term continue mean? Okay, I'm going to run the code, and you'll see it went from 1, 2, 4, 5. Now, having seen this, let's put the code in the perspective of what continue really means. Okay, it also gives us an interesting idea of how the indentations work, which tells you where the loop really exists. Okay, or where does the loop begin, where does it terminate? Okay, and we'll see what that is. Now let's look at the script. So we say that for C in range 1 to 6, that means 1, 2, 3, 4, 5, if C equals 3, continue, and notice something, continue is indented, so it's inside, it's nested inside this loop. So continue means just kind of go back to the next term, right? So it goes to 1 and it prints it out, it goes to 2, it prints it out. So for 1, it prints out, 2, it prints out. When it goes to 3, it says C is equal to 3, continue, and then it goes back and then goes to the next range, so 4 and 5. And that's why if you look at the result, you will only find 1, 2, 4, 5. Okay, so now we can go back to the script and we can say, you know, if it's 5, okay, and I'm going to run the code again, and you'll see that now you have 1, 2, 3, 4, which means when it was 5, it continued. And again, you're not going to get 6 because we go from the 0th term to the second to last term. Let's look at the script. So the script is for C in range 1 to 6, that is the same. You have a colon. If C equals 3, break. Now we remember what happened with continue, right? And again, you see the if and the print are indented the same, so that actually belongs to one loop. Now, if C equals 3, break, okay? Continue means that don't go to print, go back and go to the next range. Now, what happens if you type in break? Let's run it and see. Okay, it does 1 and 2. For the continue command, it was go back and continue. Break means essentially if C is equal to 3, stop, which means it took the first term, printed it, second term, printed it, third term, it said break, which means essentially break out of the loop or stop the execution of the loop. Okay, and you know, we can just try 5, okay, and then you expect that it will print 1, 2, 3, and 4. Okay. The points to remember in this case are the two things you learned: continue in the previous code and break in this code. Okay, so essentially it's a forced stop on the loop. 2_8, you know, very often when you print, it will print in a default way. Okay, but if you want to format, if you want to put a special set of restrictions, which actually makes your printout looks nice as opposed to whatever default Python spits out in terms of a print command, an output command, it's actually a good idea to understand how to do formats, how to format your print command so you can get results exactly in the nice way that you want to see it. Let's look at the script. You're just specifying two numbers, x equals 20 and x equals 75, and then you're printing the sum of, this is a percentage d, now, which means what are you going to get? Well, you're going to get, and then for that you're going to say I'm going to print x, and x is already specified, y is already specified, and then you want to print x plus y. So in the print command, you already have the calculation. You don't have to recalculate in any way. Okay, so the print command allows you to do this. So then you have another set of numbers, and so the d is basically an integer format. Okay, and it tells you look at it, there are three terms here, x, y, and x plus y, and it says the first term, that is x, would be in the integer format, the second term integer format, and the third term in integer format. Okay, now you're redoing this code again, so you've got a number in the floating point, and it says, so you see the percentage f for x, y, and x plus y, you want everything in the floating point format. Okay, and in the third case, and this is again how you can format things really nicely, or multiple terms can be formatted, because here they're saying that 0.2 f. So it's almost, it says we're doing a floating point number, but that floating point number is restricted to 2 decimal places. So that's 0.2. Okay, and in every case we're going to print x, y, and x plus y. And there's some commented codes that I've introduced just to introduce a little bit of to see how things change based on how I think. When I'm doing a code, I always try to introduce some some distraction or something changing to see whether that will, so that the final code actually works exactly as intended, or there's something to learn from changing things a little bit. And in this case, what would be changed would be the format. Okay, so if you run this code, you'll see that in the first case, the sum of 20 and 75 is 95. Now let's go back a little bit and look at our script. Okay, so whatever is a number is specified here. But anything anything else that you want to print, for example, the sum of x plus y is x plus y, right? And so let's look at this code again. So 70 plus 20 plus 75 is 95. 20.512 is, and again you get the number in in the floating point format, but this is just a default. But here, because again, these three zeros are essentially insignificant, the format of 0.2 f percentage will make sure that the code is therefore in up to 2 decimal places. Okay, let's look at the code again, because I had some other interesting things put there. So for example, if I don't change much else, but I leave the print of I take the first term in the floating point number, the second term as an integer, so x will be a floating point, and give me the answer in a floating point format. So we'll see how that works. We looked at it, converted to floating point, though it was an integer, plus 75, it kept that as the same, and the remaining codes are the same. Now let's go back to the script, and I had another commented section out there. So let me change comment here, and we said, for example, what happens if we had a floating point number, and we had we're giving information in floating point numbers, but we're converting everything, or we're not really converting it so much as printing it out as integers. So you look at your answers. Here you have 20 plus 75, 95. That's the same. 20 plus 15 is 35, and that is what change did we make here? And we took all the numbers that were in floating point numbers and converted it. Okay, so now let's look at it. We have 20.5, 15.2, and what you see when you convert something to the integer format is it does not it does not round up or round down, okay? And you would expect this to round to 21, for example, and this to stay at 15. It doesn't, okay? So as a computer thing, as an intuitive thing, we say, well, 20.5 something should be 21. But in the case of Python and computer programs, it doesn't. There is another term called rounding, and that's something we'll look at. Okay, so this is very important. So here are the lessons. Now, again, if you so the important lesson in this case is essentially how to format. Okay, so let me go and comment this out. And once again, whatever you wanted printed as text or as string would just get printed, and the percentage tells you that this information is in there, followed also by a percentage sign. Now, what else? If for example I switched x and y, then y would be listed first and x would be listed second. Okay, so we can try that out too. So y and x, and I'll just flip that, and I will run it. You'll see that that this just flipped the x and the y. Okay, but here you'll see that I flipped these two, so y will necessarily be mentioned first. Okay, so the format here doesn't determine anything. That's just the format, how you want things printed. But the terms that you add here, I could essentially add x plus y followed by y followed by x, and everything would be flipped. Okay, so this order is very important, and only this command only allows you to set the format correctly. This is again a group of while loops. So the same rules apply in terms of the indents. See, whatever you want indented as a result of this loop should be here. Okay, anything that you want to indent as a result of this loop should be indented further. Okay, and so we're going to create a bunch of while loops, and I think in the first set of codes that you learned, you actually learned while loops. So let's go with that print. This is the start of the program. It's not going to do anything else. It's just going to print the start of the program, and you're going to give it an assignation of x equals 1. And then it says, as long as x is less than 6, which in this case it is, print. Again, print nothing means print and just a new line. You could also print a \n, which is a special character, and then you print x equals, which is the print part of it. And plus doesn't really add anything. It just concatenates it. It just places it one before the other. And it says convert it into a string. So that is going to convert, while x is less than 6, is going to convert into a string. And then it's going to say x equals x plus 1. So now that term 1 is going to actually have become 2. Again, remember the reassignations. And then you have y equals 1. And therefore, remember what the while loop does, right? The while is not a for loop. It doesn't go over a range. So it says that as long as x is less than 6, because when it goes back, it starts with 1, but when it goes back, it'll become x equals 2, x equals 3, etc. Okay, and that's how it's going to circle. It's the same thing, print y, and then convert it into a string. So it's easy to concatenate both these and print them out. And then it's going to say y equals y plus 1 and go back and keep going back until y is 5. Notice that this while loop is nested inside this while loop. So when x equals 1, okay, you're going to get 1, and then you're going to identify a new y, and then y equals 1, 2, 3, 4, 5 is going to circle into this loop. And only when this is done do you go back and look at x equals 2. So you're going to get, for x equals 1, you're going to get 1, 2, 3, 4, 5. For x equals 2, you're going to get 1, 2, 3, 4, 5. For x equals 3, you're going to get 1, 2, 3, 4, 5. Okay, and that's that role of nesting the loop, which means this loop, because it's nested until it's completed, you cannot go back to this loop. Okay, to the earlier loop. Okay, so let's see how this works. We'll scroll down. So remember I said x equals 1. So x is printed as 1 and y equal to 1, 2, 3, 4, 5. And so you'll see that's exactly what's going on here. Okay. Now we're looking at codes that are essentially the same thing, except now you're going to have it even longer because for x equals 1, while x equals 1, you're going to go through y equals 1, and then nested inside that is z. So you're going to get, well, this is 1, this is 1, the z goes to 1, 2, 3, 4, 5. Then it goes back, x is still 1, because then you have to, because remember, this loop has to be completed before you get to back to this loop. So x is 1, y is 1, and z has to go to 1, 2, 3, 4, 5, okay? And the moment it becomes 6, then this goes to y equals 2, and then 1, 2, 3, 4, 5 for z, and then y equals 3, and so on and so on. And the moment this gets done to, this was 1, this becomes 5 and 5, then it goes back to x equals 2 and starts all over. Okay, so I'll scroll up. So we'll see exactly what happens. We have x equals 1, y equals 1, and it circles through all the z's. Then y equals 2, it circles through all the z's until y equals 5, okay? Until z equals 5, then it circles through all. Then it goes to x equals 2, y equals 1, and all the z's. And y equals 2 and all the z's. And once it's done with y equals 5, z equals 5, then it goes to x equals 3 and starts everything again. And the last term obviously is x equals 5, y equals 5, and z equals 5. Okay. And now we're trying to do the exact same thing. Remember, the while loop says as long as something is less than 5, keep circling over. Now we're going to generate the exact same results in the exact same way, except now we're going to use a for loop. Okay, so think of the I as your while x, and then think of your j as while j. Now, the only difference is we're going to print it slightly differently. You're going to print, like before it was x equals 1, y equals 1, then z up to 5. But then you didn't go to x, you didn't go back to x because your y had to be 2. And then you circled through all of the y's and z's, and then you had to go back and go to x equals 2, then y equals 1, etc. And that's how it's circled. In this case, you'll see that that we are just going to print the x and the y's at the same time, right? So it'll be, in the first case, your 0th term here in this range will be 1. And then you're going to go through 1 to 5. Remember, 5. They're not going to add the last term. So you're going to get, there's going to be 1, 1, 1, 2, 1, 3, 1, 4, 1, 5. And then that range is done. Now you go back to I equals 2. So it's going to be 2, 1, 2, 2, 2, 3, 2, 4, 2, 5 until it's 5, 5. That's how it typically ends, right? And you can see that it's nested once again. While something is nested, you cannot you cannot circle back until that entire all the determinations that go on in that loop are completed, and then you start over. Okay, and so this is basically what we're looking at. Okay, and so let's see here. Let's make this a little easy to see. And you'll see 1, 1, 1, 2, 1, 3, 1, 4, 1, 5 until we come to 5, 5, right? Now you know where this is going. Obviously, you can create another list and call it from, for I equals for j or k, and you can, for example, create a k, and then you can, which is nested inside this, and then you can write I, j, k, a little shorter, marginally shorter way of doing it, but it gives you the same pretty long result. But it's a good exercise in nesting, and you could essentially nest these ad nauseum, ad infinitum. So you'll see that this is the start of the program, and j equals 1 to 6, k equals 1 to 6, and then you're writing I, j's. So you'll see I, j, k. You go i's 1s, j's 1 until k5, then I1, j2 until k5, and that's basically how it goes till the very end. Okay, it's going to be I5, j5, k5. Okay, and again, this is all determined by the print command, and because these are strings, because this is a string, these are strings, then remember there's a reason why we convert strings, because you don't want to concatenate a string with an integer or a floating point number. That's what you're going to get. These are the errors you're going to get. So we've actually gone through 12 different codes, which is about a third of the way. And so, I'll continue in the next video, and then we can start from 2_13. Okay. All right, I'll see you in the next video very soon.